So again, welcome to the ACI Eco Concrete Competition webinar. My name is Connette Worlds. I am the ACI Faculty and Young Professional Activities Coordinator. And this particular webinar is sponsored by the ACI Committee S801 Student Competitions. Our speaker for today is the chair for this competition and will be the one to give you all the details about what you can expect from this event. Hassam Azari Jafari is a postdoctoral associate in the Concrete Sustainability Hub and Material Systems Lab at the Massachusetts Institute of Technology, also known as MIT. As a principal investigator and researcher, he has been leading different projects on the life cycle of sustainability and Nexus pavement building vehicle. His recent project on the environmental product declarations of concrete mixtures was funded by the ACI Foundation. He is a voting and advisory member of several technical committees on sustainable construction and management, such as ISO 14082, ACI 130, 130G, and 130H. Hassam has been serving as the chair of the ACI Eco Concrete Competition to promote and educate life cycle sustainability to civil engineering students. He received his PhD from the University of Sherbrooke in Canada. And now Hassam will begin today's presentation.
All right. Thank you so much, Kenneth, for this introduction. And hello, everyone. Thank you for joining this webinar. I'm going to talk about the new version of ACI Eco Concrete Competition that we will have for the fall convention. And for this competition, specifically, we will have everything set up remotely, meaning that there is no preparation of the specimens, unlike the previous version of the competition. And we need your simulation and calculation skills more specifically. So to start this presentation, I'm going to talk about the motivation of this competition. That's why we decided to go for the sustainability assessments of the concrete infrastructures and most importantly, concrete mix design. We know that concrete is one of the mostly used materials all around the world. Around 4 billion tons of concrete will be produced per year, and it's about 30 billion tons per year concrete, and 4 billion tons cement that we have around. And that's because concrete is a versatile material, meaning that it can be adapted to a wide variety of purposes like bridges, tunnels, pavements, and more importantly, buildings. And concrete is a durable material that can last for a longer period of time than other types of materials. Concrete is constructible, meaning that we can use it for different purposes with very flexibility. And concrete is available and economical. In other words, we can have access to concrete all around the world. But besides all these advantages that we have, we should think about using these materials in a more sustainable way. And how can we mitigate the environmental impacts of this concrete mixture without compromising the performance level? So we decided to develop this ACI Eco Concrete competition to get all the students engaged in the concrete environmental assessment. And we define an objective and a research questions for this competition that how can you as a member of civil engineering community improve the durability and the environmental impacts of concrete mix design. So for this version of this competition, we decided to go for the durability simulation using an approach to estimate the service life of concrete. And for the environmental impacts, we're going to use life cycle assessment as a tool to quantify the environmental impacts. I'm going to talk about each of these tools separately, and then I'll go through each tool and will give you an instruction related to the setup values. First of all, about the service life. How do we estimate service life in this competition? We are going to consider the long-term chloride penetration resistance of the concrete mixtures, meaning that we assume that the concrete is exposed to chloride attack in a marine environment, and the chloride will penetrate and eventually result in a corrosion on the rebars that you can see on the screen on this figure. And for this purpose, we are going to use Life 365 software. It's an open access software. You can download it from the link below for free. and you can use it for the estimation of the service life of concrete mixtures. And this is a good practice for the young civil engineering students and practitioners to learn and find some insights about the durability properties and how to extend the service life of concrete mixtures that are exposed to marine or aggressive environments. This is about the service life, and here is about life cycle assessment. Life cycle assessment is a tool, and in other words, it's a method to quantify the environmental impacts of any products. Here we use concrete, for example, and it will help us understand how much resources, as you can see on this arrow, on this purple arrow, how much resources going to be adopted from the environment and how much emission from our system of analysis go to soil, water, or air. And different stages of a product system, starting from raw materials extraction, production, use, and up to the end of life will be considered. However, for the purpose of eco-concrete competition, we are going to only focus on raw material extraction and the production stage. So we are going to quantify all the environmental impacts related to the raw materials extraction and production of concrete mix designs in our competition. So in the next slide, I'm going to talk about what we need for this competition and what should you do. For those who have already participated in the competition, in the two previous versions, you're familiar with the base case scenario and alternative case scenario. For those who haven't, I'm going to explain it thoroughly here. So for this competition, first you need to define a base case scenario, which is a concrete mix design, which composed of 4 different elements: gravel, sand, water, and Portland cement as binder. On the other side, you have an alternative case scenario, which is equivalent to your base case scenario in terms of the volume of materials, but you partially replace the binder by different types of supplementary cementitious materials. And it is up to you what kind of supplementary cementitious materials or SCMs do you want to use and to what extent you want to implement. And here we have 2 metrics, 2 scales, as you can see on the screen: the service life prediction and the life cycle assessment, to compare the durability and the environmental performance of these 2 mix designs against each other. So how should we define this mix designs? I'm going to talk about it in the next slide. We have some setup rules to have some consistent implementation of the mix design for every teams who want to participate in the competition. I refer you to section 2 of the Eco-Concrete Student Competition rules that you can find in the link. I'm going to share this slide with you so you can click on that and you can get all the links and information as well for your review. So for the base case scenario, like I said, you need to define 4 different constituents of concrete, and there are some limitations here. Here we set up a water to binder ratio to 0.4, so 40% water binder ratio. And for your base case scenario, you have to use 100% Portland cement as a binder. The other important factor is about the aggregates. At least 75% of the total concrete mass should be composed of aggregates, both sand and gravel in your mix design. So 25% binder and 75% of the total concrete mass is aggregate. This is about the base case scenario, and here is for the alternative case scenario. For the alternative case scenario, what is important is that you have to consider an equivalent volume of aggregates and binders for alternative case as compared to the base case scenario, meaning that you have to have identical aggregate volume and aggregate binder volume in this alternative case scenario. The other important factor is an equal water to binder ratio, which is 0.40, as you can see. And for the replacement rate, we have 40% maximum binder replacement. So the amount of binders that you can replace the SCMs, for example, with the Portland cement, it's going to be 40% at maximum. And only SCMs predefined in Life 365 software shall be included, because we only have the option to assess the durability properties or the coloride penetration of the mix design with this software for those SCMs that have been predefined. These are including silica film, slag, and fly ash. But you can use multiple types of SCMs. You can have ternary blended cements. For example, some part of that is fly ash and some other part is slag. And these two are partially replacing the Portland cements. So these are about the mixed design, both the base case and alternative case. And here we go for the service life prediction using Life 365 software. So to do that, we have to follow up a stepwise procedure as I described here. And it's quite straightforward, but it needs your time to devote to learning about the details of this software and how to appropriately adjust your mix design. First of all, after creating the project, you can see this screenshot. This is the project tab in the Life 365. Right after creating the project, you can see this on your screen. This software can be downloaded and installed both on Mac and Windows operating system, but I would recommend installing it on Windows. I both tried it for Windows 7 and Windows 10, and they are working perfectly. So here on the project tab, the first part is to define a title, which is your team name. And it's the 5 letters based on the rules that you can find in the Eco-Concrete Competition Rules version 2021. The second part, which is more important, is about the structure type and the dimensions of the structure. Here, for the sake of consistency, we would like to have a similar definition of the structure type, the thickness, and reinforcing depth, as well as the area for all the teams. So type of structure should be set as slab and wall here. The thickness should be 200 millimeters, and the reinforcing depth, meaning the concrete cover, as you can see on this figure, should be 50 millimeters, and we have the area of 5 square meters, which will give us eventually 1 cubic meter concrete. And in the third stage here, you have to define the name of your mix design. The red one is, you can see the BCS, the base case scenario, and the other one is the alternative case scenario. And after the definition of the names, you will go to the second tab. You can see that on the screen, the exposure one. And here you have to define the exposure condition of your concrete elements, the concrete slab that you have defined in the previous stage. Again, for the sake of consistency among all the teams, we would like to set a preset value of the location for the state of Florida in the US, the city of Tampa, and in a marine spray zone for these 3 inputs. And after that, it's important to design, to insert your mix design in the concrete mixtures tab. And for that, as you have already defined the BCS and ACS, by clicking on each of these concrete mix design, you have to enter the water cement ratio, the quantity, the percentage of the slag, fly ash, and silica film here. And here you have to repeat it for both mix design. So obviously here, for example, you can see that it's my, for example, BCS mix design. So I don't have any alternative or supplementary cementitious materials. All of them are set to 0. But for my alternative case scenario, there should be some numbers here based on your perspective and insights about the durability properties. And on the other side, again, we would like to set the value of the rebar volume as 3%, and the rebar steel type should be black steel as well. No inhibitor is allowed for this competition as well. So once you finish entering all this information, you hit the calculate service life button up here, and at the bottom of the screen, you can see the results, the service life on the y-axis, and on the x-axis, this is the base case scenario and alternative case scenario service life. And what you would like to have is the service life of the alternative case scenario and the service life of the base case scenario, and you will divide these 2 values. and you will get your service life score, and you will add it to your report that I will discuss with you later. So this is all about the service life simulation that you would like to do. You probably need to go iteratively throughout this process, and you will get back, you will optimize your mix design, you will change the values, and you can include this optimization process in your report as well to show what kind of trials and errors have you done to achieve an optimum percentage of the SCM replacement. And next stage is, how do we do LCA in the EcoConcrete competition? We developed a tool for this competition. It's a simple Excel tool that you can download from the EcoConcrete competition webpage. And it comprises two main steps. First is you have to insert your input numbers for the mix designs, both the base case mix designs and alternative case design. And then you will see the results on the summary sheet of the Excel sheet. It's a very straightforward Excel tool, but there is an instruction on the EcoConcrete webpage that you can go and download and use it to properly follow the stages to define your mix designs and get your environmental results. So here we have to notice that after the mixture definition that you entered, for example, on this sheet, on this worksheet, you have to identify the material suppliers in your city, whether you're using slag, fly ash, cement, and aggregate. You have to consider and calculate the distances from the supplier sources. In other words, the fly ash source, which is like, for example, the coal power plant, or for example, cement plant, to your university, which is assumed as the ready-mix concrete plant and your destination. And you should illustrate that on a map, on a Google map, to show the transportation distance, how much do you need to have in terms of road transportation, railway transportation, or waterway transportation, for example, if you are importing a material from another country. And once you calculate this transportation, you have to enter the appropriate value in terms of kilometer transportation distance, and the tool will automatically calculate the environmental impacts of this transportation. And after finishing all this process, you will go and you will check if all the parameters are inserted correctly. In other words, you will see that if all the boxes are green in the Excel sheet, did you consider a maximum 40% cement substitution? Did you consider water cement ratio of 0.4 or the total binder content as well? So after this consistency and validation check, you will see the results on the screen. It's at the bottom of the summary sheet in the Excel streamlined LCA Excel tool. And you can see the average reduction of the environmental impact in 5 different categories: global warming, carcinogenic, ozone depletion, ecotoxicity, and fossil fuel depletion. These are in the environmental impact categories that we have included for this life cycle assessment. And what we have noticed from the previous versions of this competition was that students mostly discussed the idea around global warming. But what would be more interesting and important, probably a better score, is to discuss what are the main drivers of carcinogenic, ozone depletion, or ecotoxicity, or even fossil fuel depletion for concrete production. Global warming is important, but how about carcinogenic? Did you see any contradictory results? How do you interpret the results in other impact categories? And at the end, the average improvement will be calculated here and will be considered as your LCA score in your report for this competition. So the third part of the scoring is about a written report. So first we have the service life estimation. Second, we have life cycle calculation. And the third one is the report that you have to submit and develop for this competition. It should be in PDF format. Check the due date, definitely, because after that, you may get penalized or you may not even be included in the competition. It shouldn't be more than 20 pages. We would like you to have enough illustration of maps and results to make sure that our reviewers and judges will understand your results clearly. And we would like you to have a discussion around the results and how they can be applied in a larger scale in your location. Basically, your vision about the mixed designs that you have developed in terms of the materials availability, the mixed design, the feasibility, the possibility, and the issues that they might get exposed if they want to implement the alternative mixed designs that you have developed or proposed in your EcoConcrete competition. And the fourth part of this competition would be the video recording that you should submit along with other materials, the other three previous stages. For this video recording, those who have participated in the concrete solution competition, they know that it's a relatively short video that you would make to present your results in an innovative way. It shouldn't be longer than 7 minutes. And we would like to have the participation of all team members. And it would be a great advantage and great scoring if all of you can talk and can present your results during this video. So we need the link of this uploaded video on YouTube, and it should be submitted along with other documents for this competition. And last but not least, score calculations and question and answer during the interview. So we gave some weights to each component of this competition. 20% report, the quality of your report based on a very detailed structure, which is already included in the EcoConcrete competition rule. 30% presentations and interviews, 25% durability scores, and 25% LCA score would be considered for scoring. And for the submission, you need, again, 4 different documents. First, the PDF report, second, YouTube link, and third, the Excel tool already filled out based on your LCA results for our verification. And last, the saved file of the Live 365 results. It's a JSON file that you can get from the software easily. And we only invite the top 20 teams for an online interview before the convention, obviously. So you will have the complete scores and we will have the ranking based on that. So again, I would like to emphasize 3 important documents. The first 2 ones already included in the previous slides, but the last one, it's about sharing the experiences of the previous EcoConcrete competition. There were some outcomes and some lessons that we learned from the students in the previous version of the competition. It's very important for you if you can review those points and incorporate that in and consider that when you're developing your mixed designs and when you're writing your reports and presentation. With that, I would like to thank you for joining this presentation, and I'd be happy to answer any questions as well.
Students, please feel free to use the Q&A box to ask your questions. I will be assisting Hassam with moderating these questions. We do already have a couple of questions. One says, can we get the standard properties for the aggregates in our mixed design, such as absorption or something else, or make the study of the type of aggregate that we are going to use?
Well, for the aggregate proportion of this mixed designs that you would like to develop, you should use the typical aggregates that you have in your region or in your city, for example, to manifest and to show the real mixed designs that has been already implemented in your location. So you don't need to specify the standards and the properties of aggregates for the purpose of this competition. So no test for absorption and no equipment required for this version, but you need to consider the appropriate proportion of the coarse and fine aggregates, also satisfying the maximum and minimum contents of aggregates specified in the competition rule.
Okay, thank you. We have another question that the student would like you to elaborate more on the durability scores.
Absolutely. So I'm gonna get back to the to this slide. Here, after finishing all the calculations, and once you hit the button for calculate service life in the Life 365 software, this will pop up. This figure will pop up, and you can see that one of them is the service life of the base case scenario in terms of years. For example, here is around 12.5 years, and you have the alternative case scenario service life, which is gonna be around maybe 33 years. By dividing the 33 by this 12.5, you will have a service life score here. This is the number that we are interested in to include in your scoring and in the team's rank.
Okay, do we have any other questions? We'll definitely give you guys a few minutes to think of your questions. This is your main opportunity to ask the developer of this competition, the chair of this competition, any technical questions if you don't fully understand what your team is expected to do. And again, use the Q&A box. If you all have questions after this event, this recording will be made available on demand. It will be posted to the ACI student competition homepage, as well as I will email this link directly to everybody who is registered for this webinar. Okay, so there is a question. It says, the local structure we need to apply our alternative concrete design needs to be only a structure with chloride exposure, like beach houses or bridges?
Well, any types of mixed design that corresponds to a local structure would be fine as long as it satisfies the requirements of the base case scenario, meaning that water bonded ratio of 0.4, 75% maximum aggregates, and only Portland cements for the base case. And then based on the rules again, you are going to modify that mixture, moving from the base case scenario to the alternative case scenario to incorporate the locally available SCMs and see the environmental impacts and the durability properties.
And we have another question that says, is it encouraged to make the two mixes in our lab?
Well, for the purpose of this competition, it's not mandatory, and we would suggest going to lab as the pandemic is still around the world, and we would like you have most of the work done based on the simulations that you will have, or based on the information that you have already gotten from your lab experimental results.
Okay, we'll still give you guys a few more minutes to think of some additional questions. I do want to mention I had some general questions earlier. You need a minimum of 2 people on the team and a maximum of 8. The team does need to be entirely undergraduate students. Graduate students are only allowed to participate as advisors or assisting the students, but they cannot be team members. So this should only be those pursuing a bachelor's degree. We do have another question that says, do we only have to use slides for the video and speak above it, or can we use other resources?
You can use any resources that help the judges understand your material selection and your environmental and durability results. I would encourage you watching the Concrete Solutions videos to get inspired and to learn about the processes and possible innovations that you can get and include in your presentations as well. So what we really need you have is to first give an introduction in your videos, then talking about your material selection, and similar to the report, talking about the optimization process, and most importantly, present and interpret your results, both the durability and life cycle assessment results. And at the end, we would like to have your judgment call about the selections of these materials, what would be the hurdles to, for example, amplify the selections or the incorporation of these materials as well.
Do we have any other questions? I will mention, and I will put this in the chat, if you all have questions, technical questions after this presentation, the email address that is given when you register for the competition is students@concrete.org. If you submit your technical questions to that email address, we will make sure Hassam receives those messages and your questions will be answered within at least 1 week. Any other questions? I hope everybody understands all the rules and expectations. Again, you need a minimum of 2 people, a maximum of 8 people. You do not need to have an ACI student chapter at your university in order to participate. This is open to all universities. You just need to make sure all the team members are undergraduate students. And this competition, of course, is 100% virtual. The upcoming convention, if you would like to attend in person, is $20 registration for students. However, most of the undergraduate student events will be virtual. So you can actually register for any of the virtual programming for free. And that includes the student competition, the student networking event, the student lunch and learn, and the student forum. So I don't see any more questions currently in the chat box. Again, if you do have questions after this webinar, as you and your teammates are preparing for this event, you will email those to students@concrete.org, and we will make sure those get to Hassam, and he will be able to provide you with some more answers. And this webinar will be available on demand, so if you need to review it again, you can do that. All the resources that he pointed to are on the student competition page that you see listed for EcoConcrete. Hassam, did you have any other information that you wanted to add?
I think, yeah, I could cover all this information. I would again encourage students to read carefully the competition rule, the instructions, and also the Concrete International magazine paper, just to avoid any confusion. Or if you have any other questions, of course, you can reach out to the email address that Kenneth shared on the chat box.
So if there aren't any other further questions or comments, we'd like to thank you all for taking the time to join this webinar. Again, your deadline to register your team is September 15th. Your deadline to submit all projects, I'm sorry, September 1st. Your deadline to submit your actual project is September 15th. We look forward to either seeing you all in person or virtually for the upcoming ACI Concrete competition, and enjoy the rest of your day. Thank you.
Thank you so much, Kenneth.